Live on YouTube. Here we go. All right. Happy midday. If you're able to watch this, hopefully I can distract you from what you're supposed to be doing at work. We don't see. Let me turn my volume down so I'm not listening to myself. There we go. I haven't been doing a lot of these live sessions on YouTube, but I need to do more because I think there's an audience of people that follow what we're doing here. So I'm going to quickly do a short data review session, but it's going to be focused on the Apex Pro OBD2 module. So before we get started, I'm going to put a link in the comments for the product listing on our website, so you can read more about what the OBD2 interface is and what it does. Before I go into too much detail, it's important to know that the OBD2 interface only extracts OBD2 data from the vehicle. And OBD2 is a government standard, the onboard diagnostics standard that all vehicles have to have. And it's basically so that there's a standardization of what data is transmitted over the OBD2 port, so that there's a standardized function across different manufacturers and different vehicles. So what's cool is that we can take advantage of that, and we can pull any OBD2 data from any vehicle with an OBD2 port, but there also are restrictions. Because we're only pulling OBD2 data, we only get those standardized functions. And I'll show you what those are when we open the app. But just know, when you hear OBD2, that is purely the standardization that governing bodies and automakers have agreed upon for what to communicate over the OBD2 port. When you see data that can be pulled from the OBD2 port that has things like wheel speeds, brake pressure, steering angle, some of those more fine data points, that is usually a CAN enabled, which is a network, a communication network, and only on more current and more late model vehicles have access to CAN, or maybe like a vehicle with an aftermarket ECU will have a CAN network, and CAN can communicate more complex vehicle specific metrics, whereas OBD2 is very standardized. There are minimum requirements for update rate, for how many times you have to report data points a second for OBD2, but that is different than CAN. So OBD2 and CAN are two different things. The Apex Pro OBD2 interface is OBD2 only, and I'll show you what that means when I share the app over. But ultimately what that means is that you'll get all those standardized OBD2 channels, and then it can be used on a wide variety of vehicles, but it doesn't have the specific vehicle functions that you'll see on CAN-enabled devices. So we've got the app, or the iPad screen shared. I'm using an iPad Air Pro, or an iPad Pro, 6th generation iPad, and we have our app right here. So to access Apex Pro OBD2 data, it's very much so the same as just looking at your data review. Now the Apex Pro OBD2, this is one of the test units that I have, comes in a box that looks like this. It says OBD2 interface on it. And I'll show you where you pull the data. So first of all, we'll look at the OBD2 dash. This is how you connect to the actual OBD2 unit. When you plug it in, it'll illuminate right here that it's something that you can connect to, just like the Apex Pro unit, and you can open up the dashboard. Here I get a little prompt about what the OBD2 dashboard is, and then I can scroll through and view all the gauges. So if you have an iPad, you can actually use this as a dash or supplemental display to your dash. So maybe you want to see map, fuel level, throttle position, coolant temperature. You can have that stuff displayed. You can also format it back here in portrait mode as well. At the bottom, when you connect this to the OBD2 interface on your vehicle, it will look up your VIN. It'll allow you to check codes and check engine lights. It'll tell you what those are. It'll automatically search them for you. And then lastly, you have a 0 to 60 timer right here. So now what I'm going to do, once you're connected and these gauges are live, you see data moving on these gauges. This is where you see the real-time data being transmitted from the vehicle's OBD2 port. What's important to know about Apex Pro, the OBD2 interface, the only data that's available is what's available on this interface right here on the OBD2 dash. If you do not see a gauge here, currently our OBD2 module cannot pull that data. So if you're thinking about purchasing one of these, I would recommend that you jump into the OBD2 dashboard, look at all the options, and decide if that's information that you need or not. If it is, the price point's very fair. It's $129. It works right in with the Apex Pro hardware, and it gets you all this data that you see here. If you're looking for brake position or steering position, you're going to need something that's probably going to cost a lot more and is going to be a lot more detailed or is specific to your vehicle. I'm going to go back to the home screen of the app, and we're going to start out by going into data. And we're going to look at what the data actually looks like for OBD2 data. All right. Looks like my screen share might be a little behind the 8 ball here. Give me 1 second. Let me see if I can reset this. I'm going to stop mirroring. Oh, looks like it reconnected. There we go. Okay, so now I've gone from the home screen into data, which is right there in the middle of the screen. And this session right here from our friend Kevin Romine at Road Atlanta has OBD2 data. So the way we know if there's OBD2 data is that we can select one of the OBD channels on our channel selector, which is right here in the middle of the screen. This channel selector affects the GPS image up here. This channel selector affects the graph right here. So I have TPS selected. Now, you might notice that normally it'll look like this when you first open up this page. Apex score over the track and speed, the speed trace displayed down here. But the way I know that OBD2 data was recorded is because I can go down to an OBD channel. So maybe RPM. Oh, yep. All right. I already noticed. There's RPM, 9,000 RPM, 0 RPM, distance over the track. Porsche GT3 almost touching 9,000 RPM. Right? That's really cool. We can interact with this graph just like we can with any of the other graphs. I can also look at the gearing that was being used. And I could show a little bit more about how that is calculated. I can see his coolant temperature. And then I can also see throttle position. So throttle position is probably the most useful thing to look at from a driving perspective. And it's probably the biggest addition to the Apex Pro functionality from the perspective of, hey, I want to learn more about what I'm doing. And I want to learn when I'm getting on the throttle and how I'm applying the throttle. That's what TPS is really helpful with. What I like to do is coordinate both screens. So I have TPS selected here and TPS selected here. That means that I'm viewing it both on the top right there, which is overlaid on the GPS satellite image, and on the bottom, which is a graph that gives me a little more resolution on what actually is going on. So just like with everything else in the Apex Pro universe, right, everything gets colored with a red to green color scale over the GPS satellite image. And you'll notice usually green means something that's positive, a higher value. Red means a lower value, right? And then orange would be closer to red. Yellow would be kind of in the middle, yellowish green, and then dark green, right? Is kind of how the color scale works. So what I can see immediately here, if I zoom in to a very important corner for throttle application, I can see where this driver actually gets to full throttle exiting turn 7, which is a slow speed corner onto a long straightaway. And I'm going to stop the dot, the position of the car on the track, right here where this driver gets to full throttle. I'll draw an arrow there so you can see it. So I've stopped the dot right here. What's harder to see, and it's much easier to see on my iPad, is that the crosshairs that are showing me the values on the graph down here are stopped right here. And I did that on purpose. So we're seeing our throttle position input, which is 85.88% at this point on the track, which is 2,336 meters. What's important to know about throttle position is that 100% is not always going to be red on the throttle position trace. And also 0% is not going to be displayed. What you're going to see instead is something close to 0 and something close to 100. The reason for that is that almost all TPS sensors and just the definition of a TPS, throttle position sensor, is actually the throttle plate position sensor. So it's showing you the butterfly valve that's actuating on the throttle. That is what's being measured. So as you can imagine, the car has to have some throttle input, some airflow to the engine to idle. That's why we never see zero. We'll draw an arrow down there to show what I'm talking about. We never see a throttle position measurement of zero if the car is running. We also don't see 100%, and most cars go to about between 80 and 90% as their maximum. And that is the exact same thing, right? When the butterfly valve is wide open, it might not actually be at 100% open, right? It's not totally open. It's at 85% is the maximum input. All you have to find is the flat line, right? And whatever the value is on that flat line, I know for this car in particular, it's a Porsche GT3, 85.88 is my wide open throttle percentage. So that's just some of the basic stuff we're looking at. Green on the GPS image means wide open throttle. That means we're all the way to the floor. Red means no throttle input. Red means that we're probably on the brakes, right? Not necessarily, because we could be left foot braking, right? But red means that we're not on the throttle. We are off the throttle. So we can see our braking zones really, really easily just by looking at the red images on the track. Now, what I'm going to do here that might be helpful or that you find helpful is I'm going to use this slider up here in the top of the screen. I'm going to use the slider to change the coloring on the track. So maybe I want to see where I'm not at wide open throttle. Maybe I want to see where I'm at partial throttle. And I'm going to do that by pulling back this right side. Whoops. Well, it kicked me out of the app, so I'll open it back up. And that does happen from time to time. Usually if you just open it back up and go back into it. So now I'm back in the same data session. You'll notice that my channels that I had selected and the view that I had selected was remembered by the app. But basically I pulled that slider back. That got rid of some of the green that was displaying, which is wide open throttle. So now I'm only looking at places where I'm at partial throttle or no throttle. Red is going to be no throttle, and I can just tap the lap and see that, right? I can tell, okay, let me find the lowest point of the throttle position trace, 20%. So my crosshairs are right here. That's the lowest position on the throttle trace. That's 20% throttle. So that's no throttle input, right? That's the car just idling. So I can see that at this point on the track, 22%, 20%, that's basically no throttle input, right? The driver's off the gas pedal at that point. If I go to where the coloring starts to pick up here and starts to get more orange, I can see that I've actually started to apply the throttle at this point. The driver started to apply the throttle. So that's really helpful. This is our braking zone here. I can see that the driver actually got to a pretty decent amount of throttle right here, right? 49%, and then had to get back out of the throttle again here and wasn't able to go back to full throttle here. In this particular car, the update rate and the detail of the throttle position is really good. Let's look at some other things real quick, and I'm going to focus now on the graph down here. Feel free to drop questions in the comments if you guys have any questions if you're watching the video. I can move my cursor, which is down here on the bottom, to see where I am more precisely as far as how I'm applying the throttle. And what I'm looking for in the throttle curve, you can see when we apply the throttle, it's normally pretty close to straight up here, right? Drivers are all going to apply it differently. Notice this one right here is real subtle. This one's even more subtle. Throttle position is always going to be a little ratcheted. It's always going to kind of step up a little bit because the sampling rate doesn't have to be super high for OBD2. Sometimes it's less than 10 samples per second. Sometimes it's 4 to 6 samples per second. This car is actually a pretty good sampling rate. But I can see that I'm applying the throttle right here, exiting turn 7, which is where this is on the track, that I'm squeezing the throttle initially. What we would want to avoid is if we saw a spike in the throttle to wide open throttle and then it drop really quickly, right? If we saw it go up and then drop down and then go back up, that would mean that I went to the throttle too soon, I got out of it, and I went back to it. This throttle application looks really good. Something like this right here. So let's go investigate that. I'm going to see what that is. That's exiting turn 1, or that's entering turn 1. All right, so I'm going to stop the dot where I see this first spike in the throttle trace. And what I'm looking at right here is this increase in throttle position, decrease in throttle position, followed by another increase. that usually means that the driver committed to go back to throttle a little too aggressively, a little too quickly, and then squeeze back out of it, started to release it. And based on my car's position on the track, I can see I'm mid-corner here. Oh, and I actually see that in the coloring, right? Now I can actually see the orange and the red, red to orange to red. That means that the driver was indecisive about when to apply the throttle. So in an analysis, from an analysis perspective, what I would say here is the driver needs to notice this and go, ooh, I'm having a hard time progressively squeezing the throttle there in turn one. Now we are looking at their first lap, which is one of their slower laps. So what I also like to do is go through and look at that across multiple laps. Yep, pretty big difference, right? Look at the throttle position trace here. Now I can overlay 2 laps. I can see it referenced in multiple places, and that's where we're really going to get more resolution on this. So now I'm looking at the blue lap is our faster lap. It's our 35.05. And notice I'm not just focusing on my fast lap. I want to look at everything. The red lap is our slower lap. On my slower lap, whoa, went back to throttle way sooner right here, right? Way sooner, but I had to get back out of it. Whereas on the blue lap, the driver waited, went back to throttle later. Later throttle application, meaning it's further right on the trace, but he got to full throttle. Look at the big difference here. And I'm willing to bet if I replay the lap and I watch the dots, the blue lap pulls way ahead when the driver goes to full throttle. Everybody seeing that? That's the difference between full throttle and partial throttle right here, exiting turn one. On the blue lap, the driver got the full throttle. The red lap, the driver did not. And look at the gap that the driver's put over his slower lap. I'm willing to bet it's even better on this lap. Yeah, absolutely. So long story short, this driver is not getting to throttle until fairly late, exiting turn one. This is a GT3 Porsche on street tires, meaning it's a fairly traction limited car. And this is a high speed corner. But what I would advise this driver to do is actually want to squeeze to throttle a little bit sooner. I would back up their braking point. I would keep a relatively soft brake because this is a fast entry into a fast corner. So don't want to overload the front end. Squeeze in on the brake pedal, kind of exponentially and progressively adding brake input to get that front end balanced, and then squeeze back to throttle position, back to the throttle. Want that TPS back up to full throttle as soon as we can get it there, but definitely tiptoe on the throttle. But we want to be back to throttle right here, right? Where this driver is currently on the blue lap, they're not even back to throttle yet. They only got to wide open throttle right here, right there. All right, so that's throttle position. Let's see what else we can look at here. I think we looked at RPM earlier. I'll pull RPM back up. So now we're looking at an RPM graph down here on the bottom. So now I can see RPM relative to distance over the course of the track. I can identify this as the back straightaway, right? That's going to be upshifting into our high gear. Anytime we see a drop like this, that's usually going to be a shift, right? There's one. There's one, there's one. Anytime we see that little drop and it's consistent across multiple laps, that's probably going to be an upshift. All right, downshifts, we'll see some little spikes like this. There's a spike, there's a spike. That's going to be a downshift. So now I'm looking at RPM versus distance. This is RPM, 0 RPM, 9,000 RPM. So the top of each of these crests, that is the peak RPM, right? That's our high RPM. And to figure out what that value is, I'm again going to take my scrolling device right here, my little scroller or slider, the blue or the white circle, and I'm going to move it probably to where I see the blue lap at the peak of the RPM here. I'm going to take it all the way to this point right here. All right. And now we're looking at our blue value, which is 8,500 at this point on the track. So now we can see what RPM we were in at any point on the track, which is interesting because we remember right here, our throttle position, right, was lower on the blue lap, waited longer. The driver actually ended up probably using a higher gear on this blue lap right here. See this big difference in RPM? Right here, the driver's only at high 6,000 RPM. Here, the driver's close to red line, above 8,000 RPM. So this driver probably was actually overslowing this corner on the red lap, was in a shorter gear. right? A less tall gear, probably third gear, was at the very top of the RPM range. And then on the faster lap, the driver actually did not downshift to that third gear. This is a automatic car. It's a PDK transmission, so the Porsche, the double clutch transmission that's actuated automatically. So that means that the driver carried more speed. The transmission decided not to downshift, and we see that very easily represented in the RPM graph here. If you do have issues with something like coolant, this is a great thing to be able to look at. You can graph your coolant and see where you're having high temperatures. A lot of times, if you're having issues in a certain place of the track where your temperature is getting really high, this is a really valuable resource to have. Or even if it just, over the course of the session, your temperatures start to get higher. This car is very, very consistent at, between 180 and 190 degrees. So here we have coolant temperature versus distance over the track, right? So when we're looking at this bottom slider here, the coolant display here is going to represent the y-axis. The distance right here is the x-axis. So this first one is always going to be your bottom x-axis across. The second one is going to be the y-axis up and down. And this third one is the color of the lap. So not only can you color this stuff with solid colors, blue, green, red, you can color it by another variable, track altitude, yaw rate, heading, distance. I can color it by all these different things. I can even color it by longitudinal G, lat G. I can color it by speed. So if you're looking for cooling related issues, then you can color it by speed, right? You could color it and see like, do I have issues at high speed with my coolant temperature? Green would be high speed, red would be low speed, right? We see a little temperature spike here at lower speed. This car does not have cooling issues, so this is not really a problem. It would look different if we did. If the car wasn't getting enough airflow and was overheating because of that, we would probably see this long stretch of coolant being very equal on the back straightaway, progressively creeping up. So we can see a lot of stuff like that, vehicle health. I can also keep the coloring of speed, and I can put it over throttle position. This is really helpful because we can actually see, where the driver's at low speed. Are they struggling applying the throttle? So right here immediately sticks out to me. Orange coloring, so lower speed. Look at the spike in throttle and then release of the throttle. That's the driver going back to throttle too soon, and that's telling us they probably had a little wheel spin. And they're trying to mitigate it at slower speed. Then we can also look at high-speed corners. This is turn 12 going on to the front straightaway at Road Atlanta. The driver's being really hesitant, really progressive with squeezing their throttle. So the OBDII device gives us a lot more capability for not a lot of money. Like I said, it's $129. So if any of these things are something that you want to add to your data acquisition repertoire, I would definitely recommend picking up the OBDII interface. If it's something that you're going, whoa, that's a lot, I don't quite need that yet, then just wait until you're understanding the other inputs, the other data variables, and this is something you can grow into. Autocross, hill climb, events like that, throttle position is going to be really, really, really key, especially at slow speed, more traction dependent situations where you're easily spinning the tires. We're going to plan on doing more live videos on YouTube, folks. This is a lot of fun for me. We do these on Facebook every Monday or Tuesday, just depends on the week, depends on what we have going on. But we do Facebook Live videos on the Apex Pro Facebook page every Monday or Tuesday evening, depending on the week at 5 o'clock Central Time. So we'll be live on Facebook this evening. All right, thanks a lot for watching. I'm going to wrap things up here. Again, my name's Andrew Rains. I'm the marketing director and in charge of sales. Every outbound communication you see from Apex Pro goes through me. And we're having a great time offering these resources, these tools for drivers to learn. If you have any questions, don't hesitate to reach out, comment on the video. Check us out at apextrackcoach.com.